So let's look for this presentation. It was about data visualization, and I just want to focus your attention in the importance of the visual analysis, because in the main part of the materials you will not find information about visual techniques. But when you are working with tabular data, it's impossible to understand the data without plots. And as you know now, there are a lot of types of plots which you may use in your researches. And also, it's not only to understand what do you have, but it's also about how to find errors in your calculations. Because when you calculate something on the signal, for example, you calculate the properties of the Flores complexes of the ECG signal, and you evaluate the amplitude of the signal, or you calculate the complex width, so the shape, time properties of the waves. And you may make some mistakes in calculations. It's normal situation. And when you plot, for example, histogram of distribution of the complex wave, with it, you will see that you have some extra values that break them. For example, 1 second, it means that you did some mistake and you have errors in your calculations or maybe points estimation. And you just return to your calculations and check if they are normal or not. You may create visual interfaces, graphical interfaces when you merge several plots. For example, you may plot histogram and connect this histogram with the So, for example, when you have some histogram, let's suppose that you have of the complex, so you time between 2 points. W parameter, it measured in milliseconds, for example, seconds, and you plot the histogram of this parameter. You will have regular histogram, but also you have sort of complexes with the extremely big. So you want to understand where do you have these problems. You may plot additional plot with ECG signal and construct a histogram with the callback function where you select the region. You may use a rectangle to select the region. And after that, you obtain the list, the table with the complexes. For example, with 2 points. I will call it S. O, Q. 1, Q, 2. Partition of the complexes. And here you will have the value of this parameter. And you will select some line, just click to this line, and you will open the plot with this part of signal. So it's really interesting idea when you combine several type of visual plots and allows and creates a navigation between the results. It really helps when you're doing some algorithm and you're trying to debug it, to find errors, to understand the properties of the signal, and it's important to connect the real events in the signal and its distribution within the signal. So it may be useful. I don't remember. Do you have some examples here? Not here. But for example, here you may see example. Here we have a real screenshot from the program for ECG analysis. Unfortunately, the quality of the image here is not good, but here we have ECG signals and QT interval. It's their interval between points Q and T, measured in milliseconds from property of the shape. And here we see distribution of the PQ parameter and as I remember, our interval or something like that. Actually, I don't remember. So here we have scatter plots for parameters, and you may select some point here, and you will see the complexes which lies in this interval of parameters. So actually, it's also histogram, but in 2 dimensions. Yes. And you may navigate between these complexes. The selected interval of the time. Good morning. Can someone connect? Also here we may it's not good to analyze these pictures in the screen, so sorry. And as for principal component analysis, when we have a lot of data and if they have more than 10 dimensions, it's impossible to. It's sometimes we have problems with the storage, and we want to compress the data in order to decrease the volume. We may use reduction techniques. There are a lot of ways to reduce the dimensionality, and one of them, the principal component analysis, is the simplest and the most popular way to decrease the number of features in your data set. You may use principal component analysis not only for tabular data, but also for images. And there are a lot of advantages of this method, and there are a lot of disadvantages. And nowadays, we have more suitable techniques for pre-processing of the data before classification. But principal component analysis is really easy to understand. And when you prepare your data sets for analysis, it's good to try PCA because sometimes it gives you good results, but not it's not one way to reject the dimensionality. You may see in the picture the main idea of the PCA. Hope that you all understand, but to be sure to fix your attention to this, that you have a number of features, yes, and we just transfer it to the new space by multiplying to coefficients. It's vector multiplication, and we goes from the original space into some new space with new axes actually. Just in the first axis, the first principal components correspond to the direction with the highest variance. 1, 2, 3. I don't understand. Do you have microphone? Hello. Do you hear me? Do you hear me? I don't hear you. Just normal situation with the I don't hear you. Let's continue. So, the main problem how to find this coefficient, this the highest variance. Yes, there are some math parts, so it's better to read in some during some nights to understand core idea. You have this explanation also in our lecture book with the theory from Nimuka. And here we have some pictures. Yes, how we project our data set in the new dimensions. And the main question, how many principal, could you answer me, how many principal components you will have if you have in original data sets 8 features? How many principal components? 8 features, 3 components, the first answer. Any yes? 2 answer. Just like we are reducing. When you what is principal component analysis? When you calculate linear combination of the features in order to find the directions with the decreasing variance. Yes, but if you have 8 features, you will have 8 principal components, the same number of components, but only and after that you select some number of components which is necessary for your task. You must select 2 components if you want to plot it. I need 2 components. Okay, I will take it. If you there are actually 2 rules how to choose the number of components. The first rule is I want. It's you need several number of components. And the second way, it's analyze the variance of the components and select the number of components which produce the 95% of the original variance, 90%, 99%, it depends on the task. So you just select the required number of components in accordance with the variance, with the resulting variables that you will have. And the variance of the components will be just ordinary sum. So you will see how the variance, for some example, is one example. In your case, it will rise. Variance, the first principal components contains something about 65% of the original variance. The 2 components provides you something about 83–85% of variance. So there are more components, more variance you have. And in this case, the variance and information are equal. So we just assume that we express information about data in the variance. But you may understand that it's not true. It's like an approximation. Let's assume that our information expressed in variance of the data. And actually, we have some problems because when we trying to construct classification algorithm to classify cats and dogs in this example, and we just transfer it to a new space using principal components, we may see that here we have dogs and cats, and the first principal components has this direction of the free line. And when we project all objects into this direction, we will have merged classes. They just intersect. You couldn't separate cats and dogs projected in this direction. So this, yes, you find the highest variance, but this highest variance just break the classes and you couldn't separate it. In the second case, everything will be okay. Yes, in the second case, you will say the distance between classes, and you may separate cats and dogs in the second case. So if you want to save the distance between objects and transfer in space where the distances will be the same, I mean relative distances. So the object that lies far away one from another will be also far away one from another in a new space. You need to use additional techniques. For example, TSNE technique which allows you to save the relationship between objects, but you need to calculate all these distances.
Even the first one, even if they still related, you can take the second like
yes.
Not be able to continue to tell against very feature.
If but for example, it's only example in from 2 dimensions to 1 dimension. You may see this difference. It's only an example, but in hundreds of dimensions, you could not assume which dimension gives you, which combination of features give you this separation. It's impossible to understand in real life. So when you want to save the distance, I will show you an example. One moment, I will find the picture. The problem of techniques which analyze the distances between objects, it's time of calculations actually, because if you have a lot of data, it means that you have really a lot of calculations. Here you may compare the result of PCA and TSNE for the same map. Yes, TSNE trying to save the distances between features. With poor quality. And also TSNE and PCA, you may see that you have really different results. And for some cases, TSNE is more accurate if we are talking about classification, clusterizing, and these kind of things. So actually, there are some hyperparameters of the algorithm perplexity which you need to find, and you may say that there are 4 different results for 4 different hyperparameters of the algorithm. But one more time, sometimes it takes too much. It's too long. If you want to create an algorithm which work in online, you have to select faster algorithms. It may be worse, but you couldn't choose difficult algorithm because of calculations. So here you need to calculate all distances between all objects, and it takes some time. So, but if you want to create some extra reduction techniques, you may go to TSNIP. So there are some link to the article about compression of the images using principal component analysis. And in this case, you also review the volume of the data set, and it gives you faster calculations for the next steps of the algorithm classification. And here's the example how could we separate picture to several number of components from the one component to the 70. You may also take this presentation and read the articles. And also, have you seen their video from the first part of the lecture about visualization, this video? Did you see it about global charts? No. Take this presentation in the Moodle. Yes, all presentations were uploaded to the Moodle in the beginning of the term. First 4 presentations, I think. Okay, let's move to this video a little bit.
Visualization is right at the heart of my own work. I teach global health. And I know having the data is not enough. I have to show it in ways people both enjoy and understand. Now, I'm going to try something I've never done before. Animating the data in real space. So, here we go. First, an axis for health. Life expectancy. From 25 years to 75. And down here, an axis for wealth. Income per person. 4,000 and $40,000. Down here is poor and sick, and up here is rich and healthy. Now, I'm going to show you the world 200 years ago, in 1810. Here come all the countries. Brown, Asia red, Middle East green, Sahara blue, and the Americas yellow. And the size of the country bubbles show the size of the population. Down there, wasn't it? All countries were sick and poor. Life expectancy was below 40 in all countries. And only the UK and the Netherlands were slightly better off, but not much. And now, why start the world? The Industrial Revolution makes countries in Europe and elsewhere move away from the rest. But the colonized countries in Asia and Africa, they are stuck down there. And eventually, the Western countries get healthier and healthier. And now we slow down to show the impact of the First World War and the Spanish flu epidemic. And now I speed up through the 1920s and the 1930s. And in spite of the Great Depression, Western countries forged towards greater wealth and health. Japan and some others tried to follow, but most countries stayed down here. Now, after the tragedies of the Second World War, we stop a bit to look at the world in 1948. 1948 was a great year. The war was over, Sweden topped the medal table at the Winter Olympics, and I was born. But the differences between the countries of the world was wider than ever. The United States was in the front, Japan was catching up. Brazil was way behind, Iran was getting a little richer from oil, but still had short times. And the Asian giants, China, India, Pakistan, Bangladesh, and Indonesia, they were still poor and sick down here. But look what is about to happen. Here we go again. In my lifetime, former colonies gained independence, and then finally they started to get healthier and healthier. And in the 1970s, then countries in Asia, Latin America started to catch up with the Western countries. They became the emerging economies. Some in Africa follows. Some Africans were stuck in civil war and others hit by HIV. And now we can see them all today in the most up-to-date statistics. huge difference at the same time between the best of countries and the worst of countries. And there are also huge inequalities within countries. These bubbles show country averages. In China, I can split it into provinces. There goes Shanghai. It has the same wealth and health as Italy today. And there is the poor in life province Guizhou. It is like Pakistan. And if I split it further, the rural parts are like Ghana in Africa. And yet, despite the enormous disparities today, we have seen 200 years of remarkable progress. That huge historical gap between the West and the rest is now closing. We have become an entirely new converging world. And I see a clear trend into the future with aid, trade, green technology, and peace. It's fully possible that everyone can make it to the healthy, wealthy corner. Well, what you just see in the last few minutes is a story of 200 countries shown over 200 years and beyond. It involved plotting of 120,000 numbers.
Yes, you will find, you may just write the name of the lecturer and find in YouTube more interesting lectures with visualization techniques. He also uses like histograms, when just all these bubbles just go to the axis, and for histograms with several continents and countries, and you may see the, so it's very interesting to see this visualization, and you may feel how easy to understand the idea when you see it in the dynamic, in this interesting approach with bubbles, the shape of the bubble, the size of the country, all information inside this small plot. So in this lecture, I want to give you understanding of the importance of visualization techniques. It's really a good instrument to express the idea, to express the property of the data, and also it needs a lot of engineering skills to plot all these points, to find the way how to find the instruments for visualization. In real, in nowadays, the most popular techniques include in web. So we're working with JavaScript and something like this, and we plot using libraries for visualization. G3, for example, it allows to plot interesting plots. I will show you some examples. G3. And it's also a way where you may find your professional area in-house, also to prepare dashboards, to prepare interfaces for doctors. It's really important how to represent a lot of data which were collected during the months, for example, in one screen. How to do it? There is no right answer. It's like a way for researchers how to create dashboard with all this stuff. And I just want you these ideas in your mind. It's like a way where you find your profession. You may also, but for you, it's important to understand the professional area. I mean, I forgot the word in Russian too. One moment. When you understand the property of the data, the specific features of the data, I mean health data, signals, in this stuff, you will have opportunity to find the best way to visualize it. If you don't understand the area of the data, you don't know how to visualize it in a correct way. So this is just G3 library. Let's go to examples. So here will be the code for the example. Here, a lot of different type of plots. Yes, areas, lines, bars. Let's go to something interesting. Let's go to power plot. It's not a program, it's a library for the language. It's JavaScript library, but you may see these examples with the code. Yes, there are a lot of libraries for any language which you may use to plot. For example, in this presentation, you may find this example. So this lives of this. You see the details, but there is Julia language, and it's language for science research. But there is also simple library which allows you to construct HTML tables, HTML pages with the graphic and data inside this page. So you may also create interactions, interactive with the plots. Really interesting. I will try to find example. Maybe I will have it in my note. Some examples. Yes, this is an example of the HTML page which were constructed in Julia language with simple, several simultaneous plots with the PQ interval T. Here you have mean value and range of the data during the days, and you may analyze the connection between them. And also here you have histograms with these parameters, distribution of ST segments during day and night, for example. You may also compare radiation. Here I will see, you may see that when you select their time, I don't know, this dot per 1 hour, I think, because here we have, yes, one dot is 1 hour, and you may see the distribution of the parameter in this hour. You may construct this page. Here we have also pressure, blood pressure, systolic and diastolic pressure. You also see how it varies during the day and the current position in your distribution. And we do some position. Let's see. Yes, also an example for plots. There are two days before and after anti-arrhythmic therapy. So this patient has arrhythmias. It's abnormal contractions of the heart. And we want to understand the effect of the therapy with some drug to these arrhythmias. So we are plotting heart rate during the some day before the therapy and after the therapy. And we have distribution of the heart rate for part before for the signal before therapy and after the therapy, and also number of arrhythmias before and after. So we may see that it has a lot of single supraventricular arrhythmias. It's about 500 of arrhythmias, 600 before the therapy, and after the therapy it's less. It's about 100. So we may compare the data, and also we may select some part on the plot and scale, zoom in and out some part of the day. And also here we may see a number of arrhythmias and also heat map in the up. How many arrhythmia of different types we have in this period of time. It was our research, how to prepare the page for the doctor in order to express the quality of the treatment. But it's really impossible to do for all. So you may use and you will use libraries if you want to plot something. And this is good way to do it. Also some visualization techniques, dynamic. So a lot of libraries which allows you to plot what you want. And it's good to work with several of them to have some skills. So, okay. Let's have a small break for 10 minutes, and after that we will continue. So let's continue. Now we will discuss the theory of the linear regression model. It's also important theme to give you understanding that sometimes we want to predict something. In the beginning of the lecture, we will start with small introduction, and we will discuss the problem of object representation in the feature space. We will talk about multivariate system analysis issues. The main equation, the more frequent equation in our area when we are trying to select to find diseases, is the question is, can the analyzed object be considered identical, and by what features can one explain their possible differences? When we have several objects, it may be patients, it may be laboratory tests for different patients, it may be laboratory tests for one patient during several months, for example, and we want to understand is this object or event identical or not, and how to find the how to measure this difference between objects, because the distance is something abstract. Yes. So in this example, we have the part of the ECG signal with two different pathologies. It's extrasystoles of two types. For our point of view, there is no difference in the signal actually, because some waves, and we couldn't see exactly the difference because we have no indication about these properties. But doctor has some algorithm inside the brain, and when he sees the signal, he analyzes it in accordance with some algorithm which were injected to his brain in the university. So in this case, the doctor will analyze the distance between complexes, first, yes. we may see that the distance between these two complexes shorter than the distance for the complexes before and after. And the distance after is also bigger, greater than for the complexes at the edges. So we may conclude that this contraction is out of the normal rhythm. So it's premature contraction. We have pause after and short interval before. It's like a feature of the extrasystem. Also, we may see that in this comment also the P wave merge with the QRS complex. P is the wave before the main wave. This small yes, so this wave merge the QRS complex we don't see here. Yes, and the altered P wave goes up to the QRS complex. Also goes somewhere here. So it means that the contraction of the different parts of the heart goes not simultaneous, but different rhythm. But for us, they're the same. So to construct an algorithm which separates one type of the extrasystem from another should contain this information about P wave in order to differentiate the pathology. It's really difficult. So we want to answer to this question, how to find the difference between objects if they are quite equal from our point of view. But we need to understand we need more information about this object to construct this. The second question is, how are selected objects grouped? There is also bad quality of the picture, unfortunately. I will try to. Maybe we will find some properties of the color. We will try to point to. Yes, better. Yes, we will back. So here we also have the screenshot of the program for ECG analysis. It's a working program. We have part of the signal with some, you may see it's arrhythmias in the middle of the signal part. And also you see groups of complexes which correspond to one type of the event. So here we have complexes which are similar inside the one group. But also the question, how to combine them using which property of these signals. Here we have signals, not just objects in its table. Yes. So in this case, in the case of this program, here it's using dynamic time wrapping technique, DTV. Just read more information in your free time. This technique, it allows to measure the distance between events, even if you have events which are shifted in time. Because if you will analyze correlation between these two events using standard correlation, you will see where relationship between the using it finds the points. So it see that they are similar by shifting in time. So we're just trying to find it's close to autocorrelation, cross-correlation, but it's different. The problem of this method is it's computational difficulty, high amounts on calculations. So it takes a lot. Yes. So it takes a lot of time, and there is no way to make it faster, unfortunately. And if you have 100,000 complexes during the day, you want to combine it into groups. You need to find all distances between all complexes and combine it. You will find the closest ones, just do it in order of the distances. It's really a problem how to classify, to clusterize the complexes and find the name of the group and these classes. Big problem. The third question is there a spatial or temporal variability of the described object, and what is the structural properties? Our objects changes during the time, unfortunately. Biological objects are not stable, they may vary. So how to describe this temporal variability? Changes in what properties or lead to systematic causal changes in others. For example, we've talked about it before, that, for example, breathing reflects to the ECG, or activity change blood pressure, and we need to keep in mind these dependencies and these changes. And how can you predict the state of behavior of the analyzed object? It's also a good question, and the question when we trying to predict, for example, level of the sugar in the blood after some dinner, because we want to prepare insulin dose in accordance with this predicted insulin predicted sugar level for some patient with diabetes. It's also a question which medicine want to solve. And small definition of the data mining. It's a technology that is designed to search large amounts of data for non-obvious, objective, and useful in practice patterns. And everything what we are doing here is actually, in general, data mining. We are trying to find dependencies inside the data. When you are trying to calculate correlation inside it, that it means that you're trying to find properties, some patterns in your data. When we will talk about linear regression, we will talk also about analysis of the data. And the extraction of scientific hypotheses and their subsequent analysis are too complex processes. Yes, so you collect your data, organize it into some tables, and you may see that it's not so easy to organize your data. That's actually a problem. You know that there are professional data engineer which collects data and prepare it for future analysis. And after that, when you collect and organize your data, you search for methods which will be suitable for this data and discover new knowledge about the analysis process in the initial data. And at the same time, this knowledge, as always, for any complex phenomenon, remains to some extent approximate. The deeper a real complex system is analyzed, the less definite our adjustment about its behavior become. In our case, perhaps the worst case is subject, biological subject. We don't know, actually, we know some general behavior and general structure of this system, human system, but we could not define the true dependencies. It's impossible. And the last phrase about models, when we're trying to approximate the human into some model of the human, heart, lungs, stomach, something like this. The research is constantly between the scale of complexity and the characteristics of unreliability. On the one hand, the model he built must be simple in mathematical terms so that it can be investigated with the available tools. On the other hand, as a result of all these simplifications, it should not lose the rational kernel, the essence of the problem, and the model is the simplest representation of the original object. Yes, but we need to balance the simplicity and complexity, so it's a problem. And actually, I want to highlight that the main task is to extract parameters which determine our process. These meaningful features which express the property of the model. And the better to try different variants, different features, different models, and select the best one. But actually, selecting the best is not so simple as it looks like, because we need to find the metric of the efficiency of the model. As in the example with arrhythmias, how to estimate the quality of their treatment, amount of arrhythmias or not. Because, for example, if you had, before the treatment, you had 100 of arrhythmia in supraventricular type and 100 of arrhythmias ventricular type. After the treatment, you have 0 supraventricular arrhythmias, but twice amount of the ventricular arrhythmia. So you have unbalanced results. One could be better, second one would be worse. And what you may conclude? Something changed, okay. And what should we do? It's a problem. And which approach is better? It's a good question. And when we will talk about classification, we have a cursor, sensitivity and specificity. It's a metrics which are suitable for classification, but also it's not a gold standard. Sometimes it's a problem how to find the best. What does it mean, the best? How to measure this bestness? So it's also a problem. And the main rule for all our algorithms, garbage in, garbage out. So if you have bad quality of the initial data, it means that you may do what you want, but you will not have good results. But if you prepare the features, the parameters of the model with the sense, with understanding of the problem itself, you may prepare these cats and dogs and plots when they are separated in your initial data. It means that you may use simple model to have good results, even if this model is simple. I mean, classification model. So it's really, really important to understand that preparation of the data, it's 80% of your time when you do some algorithm, and it's really, really important. That's why visualization is our instrument for selecting good data. Okay. And there are several data mining and machine learning tasks. Machine learning is some part of data mining because data mining includes also techniques for data collection, data visualization, and everything which what help you to make some conclusion about relationship in data. But machine learning is something about learning of the to find the efficiency of the algorithm, to solve these tasks, to classify, to find the regression model, to cluster your data in some parts, and classification. It's supervised learning when you have labels for data, when you know pseudosa, aubergine, color, you have labels of the objects. For clusterizing, you don't know name of the flowers, you don't know how many flowers types you have inside your data set. It's unsupervised learning when you don't know labels. Identification problem, it's also goes to computer vision, for example. Forecasting problem, weather, it's also when you maybe you know, for example, Yandex weather, when they are predict in 2 hours rain, you may just see the rain clouds in the map. It's also they are using prediction models to forecast the weather. Knowledge extraction tasks, when you extract from text some information. And in our case, medicine, the main problems, it's small volume of the training sample, the problem number one. Incorrect input data. It's also when the doctor just writes some information about the patient. When patient gives us information about himself, you could not check if this patient is smoker or not, for example, but you want to construct an algorithm which predicts the cancer of the lungs, and it takes it as a feature, but this information about the patient may be incorrect because the patient wants to write because my mother doesn't know, so I couldn't write it, I'm a smoker. So yes, and overfitting. We will talk about it later. When you have a little data set for training your model, find the curve between classes in accordance with this data itself. For example, if you are trying to learn your child and this child may look only to your cats, only to one cat, or I don't know, 3 cats with the same color of the fur. It means that these children may assume that only one type of cats exists in the world, and when we will see some Maine Coon, for example, she will think that it's I don't know, lion, but not a cat, because this child didn't know this type of cat. So they just know one type of cats, and that's all. And the model will behave the same. If the model didn't see several variety of data, it will remember only one type. It's when you have small amount of data. If you have specific techniques of the learning.
Just like why was there this investigation that overfitting something else than the small volume of training something the same? So like when as you said, when you told the baby that every single animal have four legs. So anything you can see, you can say that. So anything using 4 legs.
Yes, it's close. Overfitting may occur not only because of small amount of data, but small amount of data may occur overfitting, but may not occur. It depends on the algorithm which you are using. because you may use logistic regression data nodes. Logistic regression doesn't have overfitting in general because it's a stupid algorithm which constructs a plane. Overfitting occurs when you have algorithms which calculate, which may construct separation surface with angles with some curve, non-linear. It provides overfitting, but not all algorithms may overfit. Okay, and let's go to linear regressions, our second type of problem, regression problem. So what is it? Linear regression is used for finding relationship, linear relationship, you might understand it from the name of the methods, between targets and one or more predictors, two main words, you know, target and predictor. And we will talk about simple linear regression when we have only one target and one predictor. In multiple linear regression, we have several predictors. In this example, in this picture, you may see linear regression for two predictors and one target. Predictors here, years of education and seniority, and the target is the income. In this case, we have a plane. Yes, it's a linear in three-dimensional space, and we want to find the equations which express this plane. And you may see also that this plane close to the trying to fit on the some sets of objects in this three-dimensional space. In our case, we will work with, as I told you before, in two features, yes, predictor and response, or predictor and target, the same names. And we will find the relationship between two continuous variables, predictor or independent variable, and response or dependent variable. It's a statistical relationship, but it's important, not deterministic relationship. I just highlight this idea, and you may write it somewhere in your notes of this equation. I really strongly recommend you to write. It's because your brain just look into the pictures and just thinking, I understand it. When you go to home, you will not, yes, you will forget what did you done during 4 hours. Deterministic, what does it mean? That it's you may calculate one from another using equation. It will be with 100% of accuracy. So
like the same equation without the error.
Yeah, exactly. So what do we have in this model? It's a model of linear regression. Yes, this is linear regression model. We assume that our dependent variable may be expressed as a linear component, linear expressed using from, you know, this equation from school. Then you have B0, some free constants. You have constants for independent variable. This is linear component and some random error components. So one more time, we assume in using linear regression model that our dependent variable connected with the independent variable or predictor by a linear relationship and some random error near this line. The Deterministic relationship is like a recalculation of temperature in degrees of Celsius to Fahrenheit. It's also a deterministic relationship. Or how to calculate weight in kilograms and grams. You may calculate it using the absolutes. Yes. What does it mean also for us? That we may use this method only for data which corresponds to this idea. We may use linear prediction only for linear dependency inside the data. Yes. So we will see. We will talk about it a bit later. How to analyze if this method is suitable for our data set or not. In our practical task, we will work with two data sets. The first one will be suitable, and we know it. And the second one will be unsuitable. And we will try to find this information in some metrics. The suitableness. So we are trying to find the line which express this linear relationship, and the error between prediction and true value should be as less as possible. How to measure this error? Just fix your attention that this distance is like a vertical line, but don't calculate the distance like this, perpendicular. It's a mistake. Yes. So it's sometimes it seems that it will be correctly, but this one is not true. It's not a mistake. Mistake, it's a distance between real value or predicted. And we are trying to find the line which gives us minimum value. And you may see that red one, it's a real value of data in your data set of your response or target. And the red or the green cross, it's predicted and predicted with the head. It's head. No, I don't remember the correct name for this sign. So error, it's we calculate an error in square because we want to delete the sign from the error. It will be every time it will be positive. So you may subtract prediction from the real or real from prediction value. It actually doesn't matter for the results.
Just for not negating each other, but maybe value from both the line or the value.
Yes. So you will have all errors positive. And total error
Line should be perpendicular.
not. So this we need to look to this zoom in part. So
Yeah,
this
but I can get it. Like maybe 3D would be like this.
no, it's normal non-distance difference between two values. And you may see that prediction here
because it's compared to different lines.
yes, and if you plot it somewhere here. We actually hear it. This difference. Yes. So. Actually, it calls residual. So, Victor, target, or response residuals. it's an error in one observation. Without square. The square will be error. Total error may be calculated as the sum of differences for all objects in the square. Here we have linear regression equation without error because in our line we don't have error here. Yes. And the problem is how to find so we have x, we have y, how to find b0 and b1 for our existing data set. You may know, you may find the first derivative of the equation and compare it with the 0. It will be extra roots of the function where function derivative is equal to 0. It's extra maximum or minimum of the function. So you may find the point of the minimum and solve the equation. And you will obtain the solution for the minimum problem. So we will not do it, but if you want, you may find information on the internet how to calculate b0 and b1. But actually, in order to find the best solution for linear regression problem, we calculate the derivative of the function and solve the equation with the derivative is equal to 0. And from the solutions, we select not for the maximum, but for the minimum. And it will be this one, b0 is equal to average value of the y minus b1 to average value of the x. It's average value, yes. And mean value, average value is the same. And for the b1, it will be this equation. You need to find the sum of differences between x each value of the x minus mean value, average value of the x, and that's all. Here huh? Yes, yes. We have observed x's. You see that here no predictors. Here in this equation, no. X is a predictor. Yes, yes, yes.
We have the same in the control system. So X is the observed or predictor, and Y is the response. Yeah?
Yes.
So yi is the response each time for n observed for
one predictor, one response. For each x,
or
you have
maybe you have 4 predictors and 1 response.
Yes, you may have, but for this case only one. Yes, it's a simple regression.
Yeah. So
here we have
the mean of x mean.
Meaning.
Yeah. The y means the
So please write this equation somewhere because we will program it and you will need this under your eyes. In the second part of the class, we will program this equation. So write somewhere. Right now. Write equation for B0 and B1. You will need it in the second class. X mean?
Yeah.
It's the average value of the data set, mean value of the data set.
Yeah, what means was each x is input and each y is output. So the x mean
Just mean value of expression. arithmetic mean.
For all inputs. But
Just take all your objects. Divide x. So when we will look closely to the coefficients, we will understand that they are also informative for us. If we find that P0 is greater than 0, it means that we have positive relation between two values. And it's less than 0, it means that we have negative relationship. In case of multiple regression, we may also compare the coefficients, and if coefficients graded mean that the relationship between this feature and the predictor is stronger than for the other. So also explain the level of the dependency one feature to another. P0 is also informative. Sometimes it's if our model contains objects with the 0 predictor, we may see the result of the model for this value, but it's actually not very common. You may also calculate these coefficients. In this case, it calls theta, but it doesn't matter. Using matrix form. Here, X it's a matrix. T means transparent matrix. Inverse matrix of the. It's like actually it's square of the matrix. Multiply transform minus 1. I also use this equation. There are a lot of several ways to calculate coefficients, so you may select everything you want. If you will find some additional equations, it's also okay. And as for residuals, the question was from you how to understand if this model is suitable, do you have linear dependency or not? As you remember, prediction contains of deterministic part, which we may express in the line, in the regression line, and some stochastic or statistical part. Yes, stochastic part reveals the fact that the expected and observed value is unpredictable, and there will always be some information there are missed to cover, and this information can be obtained from the residual information. What is it? For residuals, it's a difference between predicted values and actual value. So we just calculate this difference. Remember, it's not a perpendicular to the line, it's normal difference between real and predictor. And you will see that these orange points here, these reals here, and you just change the actually like in principal components exposed to these plots. You will see how errors without square varies near the line of the regression. And this residual analysis is the main part of the analysis of the results of linear regression. It's a scatter plot. You will work with scatter plots in lab number 3. So you maybe if you started, you are familiar with scatter plot. And actually, here we have standardized residuals, so we may divide it into standard deviation to be sure that we have the range, standard range. Here, predicted values or reading. So, and one more intention here, we have predicted values predict and actual values. But residuals may be calculated in different ways actually. Predicted and standardized residuals, as also residual plots, and its ideal results. What does it mean ideal? What do we want to see when we construct linear regression? Actually, residuals may be plotted not only for linear regression, but any type of regression, and not only regression, for many other algorithms too. They are pretty symmetrical distributed, tending to cluster toward the middle of the plot, the first property. They are clustered around the lower single digits of the axis, second property. In general, there aren't clear patterns. These three points should be observed in our residuals, and we need to check these three parts. What does it mean bad residuals? Bad residuals mean that our model is not suitable for our dataset. When we see that plots aren't evenly distributed vertically, or they have an outlier, or they have a clear shape, it means that we have bad residuals, and we need to change the model. If you detect a clear pattern of trend in your residuals, then your model has room for environment. What is, for example, in this case, you may see the parabolic quadratic relationship, and you will see it in your practical task. This example, that we missed this quadratical relationship. So we need to take this dependency inside the model from residuals. The residuals should be random. If you have some dependency, it means that we missed this deterministic part in our model. So we need to return to the model and improve it. If you have this tendency, it means that our residuals are heteroscedastic. Heteroscedasticity, it's a property of standard deviation variations. When your variance varies in time, not in time, during some axis. So it means that you have unstable variance. No, it's bad. Your variance should be stable for all residuals here. So in this case, you have randomly distributed residuals, homoscedastic. What? Homoscedasticity, it's a constant variance. Homoscedasticity, you need to remember this word. So homoscedasticity, it's when you may find some range where your data lies inside this range. Straight lines, parallel straight lines. When your variance varies, you will see some strange shape of the dots. So it means that also it means that you could not express your data set using this model. In parabolic case, we just need to go to the model and add quadratic dependency in our deterministic part of the model. As you remember, we have deterministic part and some statistic variance. So if we have a relationship, we may return to the model and change the model. Yes, so we may do nonlinear but quadratical dependency. Why not? There is a lot of types of regression actually. We're just working with the simplest one. So any other problems and how to find the problems in residuals. We may plot the histogram. And we see that we have outliers. We have unbalanced y-axis. We have heteroscedasticity. It's non-constant variance. We have non-linear pattern inside there. We have also, again, outliers in the residuals. Maybe we have problems with our data, not only with model. Maybe we need to return to the data set and look to this object. Maybe we have some problem here and we need to change it. Why outliers is so important? Because as you remember, when we calculate B0 and B1, we calculate means, X and Y. But average value is sensitive to outliers. And the line will be not very good if it will change the angle to outlier if you have something in the data far away from the main plot. Large y-axis data points. Yes, we also want to detect these residuals. And one more time, I highlighted here we have standardized residuals. When we standardize our data set, we divide it into standard deviation, and it allows us to compare different scales. X-axis unbalanced. So actually, again, we have unbalanced residuals. It was all about residuals and visual analysis, as you understand. So we just look at the plot and may make some conclusion. Actually, one example from real life real problem. I will show you my the question from my colleague. It was the question, what do you think? Are they homoscedastic or nurse? Oh, I think that's bad residuals. It's really, really strange shape, just like a W. So it means that we missed some information about the deterministic relationship. It's a good question how to delete it, how to remove it. And Mike and Evgeny said that there's strange notation that I see the problem, but when I calculate the metrics of the quality, there is no problem. So it's really, really important to analyze the residuals. Okay, how to measure using values and compare the results of models, how to select the best model using some metrics. There are several approaches. The main metric for quality of the regression, for any regression, it's R-squared net value. We need to, it's close to correlation actually. It also varies but between 0 and 1 because it's squared. And it indicates how good your predictor express variations in the response. So it's actually part of the variance. It means that 81% of the variance may be expressed by predictor. So revenue maybe 81% of the revenue may be expressed by the temperature.
So R-squared is standard deviation.
No. It's not a standard deviation. We will go to the formula a little bit later. It's close to coefficient correlation.
Correlation.
No, it's not close to standard deviation. It's like correlation. It's squared actually. And actually, I recommend you to write it somewhere because you will need it. Regression sum squares, as are. This information, how far estimated regression line regression line is from the horizontal line, which means no relationship. Average of actual output. So we just calculate how far our predicted values, yes, this predicted values from the mean values of the real target. And of course in square, because we want to positive values. Huh? Yeah. So because if you have if your regression quite close to the mean value, it means that that you could not express the variance of the y using x. So it means that your relationship between x and r will be quite weak. So regression sum of squares. Some squared errors. We will have different combination of words, squared errors and sum. So, how much target value varies around the regression line? Here we have, actually error from the first slides about the regression. Here we have mean, but how far from the mean? Where is this picture? Here. Yeah, you just, this is finding the mean value of the y, and calculate how the predicted values will rise.
We are calculating from the line itself.
Yes, it's a regular error. It's only metrics of quality. It's not for for B0 and B1. It's quality metrics.
Why without anything is the
real object value. And the third parameter, total sum of squares, tells how much the data points move around the mean itself. In the first coefficient, we have predicted values. Here we have real values, variation from the mean. So we just, this parameter estimates actually true. If we have 0 SSTO, what does it mean? It means that all our values lies on the line of the mean. And it means that when the predictor changes, the response doesn't change the value. So we have the same target for all predictors. So we have no relationship actually. And in this case, if you have small SSTO, R squared value will be 0, quite closely to 0. So an R squared value calculated as 1 minus sum square errors divided by total sum of squares. You may also use this equation. So, and some additional points about correlation coefficient. This is related to value of R squared, which can be observed from the notation. It ranges from -1 to 1. And actually, as for correlation, when the value of B0, V1 is negative, then correlation will be negative. So it's also square correlation. That's all for linear regression. So we will calculate the predictions today. And as for serials, I think that you need to understand that you need to analyze homoscedasticity, that there is no patterns inside the data and there is no unbalanced groups in the data and outliers. It allows you to make a conclusion if this model is suitable for your data set. If no, you just change, you may back to the model and change it. Actually, there's a good article about residual analysis. I couldn't find the link, unfortunately. But it's good to read it. Trying to find this article right now. If you Google residual analysis plots, you may find the link to Patrick Holm. It will be the first one. It will be about analysis of the residuals, and actually gives you good understanding of the results. We go through this text, how to go from the model to residuals. Actually, residuals observed minus predicted. Yes. That my pictures was from this article. Example in their diagnosis, and you may also see how to fit it. Very important. The problem definition and the solution. How to fix. Transform your data. You may also transform not model, but you might work with your data. Important comment that heteroscedasticity, unstable variance, indicates that a variable is missing, so you may miss some. Yeah, some feature. Also, how to fix variables need to be transformed. Need to create a non-linear model. You may also, so you may think this. I will send you a link. Okay, please share this, guys. Helps you to understand the problem. So, do you have questions about this thing? That's good. In this part, we will work in MATLAB, and we will try to do the second part, the practical task. So you may go to computer and turn on MATLAB, open MATLAB and task. In this task, you will see that we need to implement the function for calculation of the coefficient B0 and B1 using the least square method. Least square method, it's a method that we use. So we need to minimize error, yes, and estimate B0 and B1. In the previous process, we did linearly dependent data, and as I remember, you had to do quadratical dependency. Did you do it? Right, expect. So let's create functions. You need to do the report. We have our equation. Let's open the previous script. Yes, of course.
We do last time was just making random error, not
The report will be, you need to prepare the report when you will finish the full task. I will create one more time. No, of course. So, no. You need to open previous code. Now you need to repeat, but if you have previous, I just want to restore the previous example. So
Yeah, but I need kind of
it's normal. You may do it in your way. You don't need to repeat it directly as I am. So if you want, have your idea of how to do the same things, but in different ways, normal. No problem. It's a little bit slower. Right, my figure. Again, squared matrix. Transpose it. Transpose X. So, to do my example. Let's suppose we have because X has dimension 1 to 1,000 and error has dimension 1,000 to 1. So if I will put the sum of these two matrices, I will have squared matrix 1,000 by 1,000. I won't have vectors, so I need to transpose some of them, X or error, and I will have 1,000 to 1 matrix. So let's calculate our B0 and B1 outside of the function, right here in the script. We'll start with it open one more time. So we will start with B1. We need to calculate mean value of X and Y, so let's do it before the main script. We will use standard mean function and for Y and for the X. Let's run it. We will see that we have one value, the mean value of X, mean value for Y. And that, let's back to calculations. We will have two parts, and in the numerator we have sum of here we have X minus mx dot multiplied by minus ly. Here we have sum of X minus value power. So don't forget to use dot before operation because we need to multiply element by element. Here actually we need to find the square of the elements. Let's run it. Oh, not xm and x. V1 is a vector, so we did some mistake here. We forgot to add something. X and Y has different shape. You may see that they are transposed. So let's transpose not X here, but I prefer have the shape like Y. So here I will transpose rerun this part. So B1 will be equal to 6, 5, and 9 for in my case. It's close to my original B1. So it will be B1 predicted. Here will be B1 real. Let's add suffix. We just change the name to be sure that we will not recalculate the values. And let's add equation for 0. Predicted. B0 predicted in my case is equal to 2 and 6. Now let's plot these predicted values to the chart. But before, let's calculate predicted Y value will be B0 predicted plus B1 predicted multiplied by. Y value is that in real life you don't have B1 B0. Y it's only just value of the response.
So here when I before, so
it's another part. So this is part when the model subtype set. It doesn't connect to the second one.
No, okay. So now I should have Y index.
Yeah, yes. So we need to read this part from this script. Creating function which will calculate B0 B1 in the base of X and Y.
So here I have Y.
Yes.
Why should I predict the
0 and B1? Because we want to create a linear dependency to predict, for example.
Because maybe I didn't get it. Y is the output, X is the input, and those will be predicted. The non-observed, sorry, not observed, predicted, not predicted, and the output and V1 and V0 is featured.
One more time. In the first part, we just model some data set. We may use. So
I'm just asking V0 and V1 what definition is. Yeah, just conditions for what it represents the system.
They represent the dependency to Y and X. So in our
the feature.
it's not the feature. No, it's not the feature. It's efficiency of the model which you are using. It's only parameter of the model. If you choose another model, you will have another coefficient. It's not the property of the data itself. It's property of the model. So we have some data set and we are trying to estimate parameters of the linear regression. And also I forgot to say you about using linear regression in real life. It's not only to estimate the dependency between x and y, it's also to predict response for new input data. For example, you create a regression for the predictor will be area of the house, and the response will be price of the house. You have some data set where you have already sold houses. You know the area in meters square, and you have some price in dollars. And you want to predict the good price for your own house. You may create a link, you're just plotting the regression, and you may find the normal price for your house. In case of sugar level, we may also plot the regression and predict the level of the sugar in accordance with the number of fats and sugar in the carbonates in protein in the food. So we may also predict the new value when we know this line dependency. So we may predict in we are calculating predicted 0 and V1 for some data sets. In real life, we don't know the real property of the system. In our case, we just model this data set to be sure that we have linear, truly linear dependency with some error. So let's plot y predicted will be so we may see that our blue line is quite close to the red line. A red line, it's a real dependency between data sets, so it's this part. The blue one is the predicted B0 and B1, which we calculated using our model using the square. You can see there's little difference. Let's add some, let's play with x and add some outlier to the system. For example, x from how many points we have? 1,000, 100 to 200, or 250 will be multiplied by 10. Let's do the same. Sorry. Oh, to y to the x. So here we have, if you have some outliers in our data set, you may see that the distance between the lines will be greater then the without outliers. Here we have abnormal situation. So this relationship is non-linear in the beginning of the plot because I just add some noise to the data, and the angle of the line changed because we have some outliers. It will be upper to these outliers. Means
So to find out.
you need to apply this model and to estimate the residuals, estimate the R square value, and see what do you have. So, and after that, you may make conclusion about suitable this model or not. So let's create new function which will calculate the everything we did. So just copy paste this code to new function, and I will open function. Now I will upload this video to YouTube. You may repeat this. So let's create new function. Let's create new function for you. We will return v0 and v1. And as input values, we have our predictor and response. I will call it calc of account B. That's all. So save this function. The name of this function should be the same. And we may use this function instead of previous part of the code. Oh, I have an error because I forgot to. Huh?
I thought you were saying that we are using that.
I don't know why, but I couldn't open the file to change the name of the variable inside. So small problem, but actually just be separated into new function. Let's go to the task. What test data, and so is it clear how to implement the function for calculating E0, 0? Yes. So in the beginning, the third part, plot test data and regression line. It was our figure, yes, scatter plot in line. Calculate its e-value, coefficient of determination, and show them on the chart. So you need to use the equation from the presentation and calculate its e-value and R square value for two data sets, linear and quadratic. Yes, so you repeat the same for two data sets. How to add the text to the figure? You might add it as a title. I don't know. I just suppose that SSE is equal to 10, R squared is equal to 0.8. For example, you may add it to the plot. You may use plus in order to merge the join to strings. So you might just use this to str. So add. And like this, you may add text. You may also add the text inside the figure. You will find information how to add some text box to the figure in the documentation. So what does it mean? It means that for the next week, you need to bring the results of first 3 steps and show me in the computer the results, okay? You may also go to recitals if you have enough time, and also spearman rank correlation test and both one tests. We will discuss what is it later, but you may also read it by your own. There are some additional links which you might follow and read information about the square methods. Everything okay? I forgot to add demonstration on the screen. Sorry. Okay. I just show the code. So you need to go to add this part with calculation of square method to the new function, and you will see the results. Modeling, calculating the line. Here we have some mistake of calculations. It's normal because we had outlier before, so we rerun the code. Here you may see the original red line quite close to the predicted line, which is blue. Okay. The first link from the task, you may open it at home, allows you to play with the data points and see how this line changes. Here we have an example, dependency between height and hand size. Also, you may find different errors. Yeah, it's some error between, you may see predicted value and real value, and in squared because it's squared. Actually, we calculated square. And here we have two-dimensional Here we have two dimensions of predictor and how the plot, the plane varies, change the values. We may also change the value of coefficients here, and we will see how this model changes. Interesting discussion. You may also go to this web page, Setosa.io, to play with the data. You'll find visual explanation of main principles, and also, for example, principal components, how it varies when you change the data. Probability visualization. Okay. T, S, and E. So that's all for me. Please continue working on your practical task. Free time. Next week, for not the report, but just code to show your results, to discuss it, and don't forget to break quadratical dependency between y and x, to organize it in functions, and to use the main script for plots. And also, please prepare the lab work number. Let's open the plan, okay? Mm-hmm. And I think that next time we'll have test number 1. Test. It will be about first lectures. It will be some matrix operations, just to be sure that you make matrix operations to multiply, vector by something.
So it's something from the
Paper, yes. It will be open questions. Not for students abroad. It will be some tests in Moodle, but only for abroad students. It will be measurement system chain. It will be some ideas about event detection, and it will be some open questions to think what you may some example from the signal. You need to find some features which express the difference between some events in the signal. So
on that level.
no, just I need your ideas. Yes, just your ideas. How to divide several events into groups. It will be questions about histograms and visualization techniques, to make some conclusion from the plots, to answer the questions when you see some plots, answer the approximate mean value of the parameter. Do two groups intersect, or they are quite separated one from another. And also, we will talk about it will be questions about PCA. So read closely the lecture materials, PDF file. You will find it. So it will be in the first.
Lectures, the lab work, the practical tasks we covered.
Yes. Just to be sure that you remember all these materials, and I will call this today lecture also or in YouTube. And in the first week of November, we have day off. So it will be time to do the third and the fourth lab works. And after that, we will go to minimum distance classifier and LDA. So we'll go to the new part of the theme. It will be classifiers. So we started with some introduction, visualization, PCA, preparation of the data, linear regression, and after that we will work with classifier techniques. Okay, perfect. So I will start.